Alright, well I think we're gonna be live here. So today we got these little snowman trinkets that I'm making. Had a few that I pre-opped earlier, kind of just for reference of what we got going on here. I couldn't finish the engraving part of it that I wanted to get done for today, but we're just going to be doing, kind of making these snowmen and tapping these little holes, and then making some little arms for them over here on the fourth axis. So then the snowman blanket's done over on the lathe, and I just had some difficulties with trying to get what I wanted done for the engraving in time, so just going to be leaving that off, maybe add that on later, get some videos for that when I add it on later. So right now we got inside the fourth axis here, we got the little snowman blank off the lathe. We're just going to start over here. Because the drill actually comes in over on the sphere, we're starting off with an end mill for a spot drill actually. It's just going to leave a little flat, then the drill is going to come in, it's going to tap, and it actually is just drilling. It's going to be like spotting, drilling, and tapping from both sides instead of trying to go all the way through, just to show the fourth axis and being able to show the capability of it. So even though I could go straight through with what we're doing, it's just kind of the reference that you could do multiple angles if you wanted to later. So we're going to get this program started here. And I do have it running with no coolant just for video purposes. I do have coolant coming in on the tap though. So again, this tool just coming in and kind of making a spot in the location that the drill is going to come in after it. And because it is a split point drill, I don't actually need kind of like a countersink for that drill to kind of come in after it. Changing that one out. Got our drill set up over here. Now we're going to be running this drill, and again, just running it with coolant just for video purposes. Ideally, you would want to be running this tool with coolant for what we got going on. And that's why I'm kind of pecking slow and going a little bit more slow and conservative with this, simply because I don't have the coolant on it right now. But if you were running coolant, you could essentially just push this drill right through the part. So we're coming back to the other side. Then after this one gets ran, we'll go over to the lathe and kind of show what we got going on over there, and then kind of get them running back and forth. So now it's giving me my warning to change out for my tap. And again, I have coolant coming in for the tap here. Probably maybe a little bit of splash up on the camera. We'll see how bad it gets. And again, because we're coming from both sides and the depths of what I'm doing, I'm just putting the screws in from both arms, so I don't actually need the tap to go all the way through right now. I just need a little bit of depth from each side. So and after that, I would have been running the engraver program that I just unfortunately didn't get done in time. But right there, that is actually just the end of that program for what we got going on now, and then I'll just show what we're doing with those after we get those holes in it. So I got this extended out how I did because of how I was going to be using my engraver. The tool that I had, if I can just show the reference here, for getting down in here on this face, I wanted the extra clearance from this collet, because when I was trying to do it over here, I was getting too close to running into there, and that's where I just didn't get the program exactly set up how I wanted to at the time. So and then as we got the tapped hole in here now, so we got our little 1032 screws that we're able to throw in. And then if I wanted to, I could take this over to the lathe or just belt sander, get that little nub off that comes off the lathe, and we'll go show how that's running on the lathe now. So over here on the lathe, we got our stock sticking out. I already have this one kind of sticking out to the length that I needed to for the first cut, just for setup purposes. So we'll just run the program from the start. So this first tool, it actually already took its pass, but we'll just show it for demonstration purposes. And on the next one, it'll actually be taking material on that first pass. So it just comes into 0. I actually have the RPM running a little bit slower and going a little bit slower here because of how much stick out there is there at the end. I had it going a little bit faster earlier and just didn't really like the results of it, so I just slowed it down a little bit. But when it goes to start doing the profiling for the actual snowman shape, then it starts to speed up a little bit. And I did add in op stops in between my tool changes here, so I'll actually have to hit cycle start in between tool changes. But I can always turn that off if I need to later over on this main control. So now our profiling tool is coming in. Make a little bit of noise for the interrupted cut. And again, we're just running this one dry for demonstration purposes. Right now it's kind of just doing the top hat. You should be able to see it as it comes in a little bit more later. While that's running, I should be able to get another little part loaded over here. I think I had one pre-set up. Grab another little one. See if we got any questions here. Yeah, I really like the 770, especially just for being able to plug it into like any normal wall outlet, where when you step up to the 110, you got to have like accommodate for the 220 plug. Not that that's a huge issue. I just really like the versatility of the 770, and kind of its smaller footprint also, when you got to get it into a really limited space. I'm going to change my tool back out to tool 1 for over here. Make sure I don't get too distracted. My right tool in. Then we'll, guess we can just look at the video and go see what our snowman's doing here. Okay, so it looks like it's still at the front of it. It's almost done with like essentially like the headpiece right here. And then after the snowman, after this tool is done over on the lathe, it's going to be the part off tool that comes, and then we're going to be able to grab the part out of there. So we got our spot done over here. Throw the drill back in. Give it the little spin for flare like I always do. Get that drill going. Then while that's running, double check back over here. And it looks like that one's just doing its little flex. Maybe it's its finished path right now, and then I am running a flex path on it at the moment. I'm just trying to maintain my diameter, even though it's nothing critical. I just want the right diameter for going over into that other operation for maintaining my zeros and stuff. Yeah, now it's doing that little flex pass. Should be able to run this other tool before that's ready to go. Again, got our tap in here now, so then coolant's going to come on for this one. And one side and out. And if you notice the little facets on the face of that bottom part of the snowman, that's simply because we're using hex stock over on the lathe. And I thought it was kind of cool design with how it ends up leaving little circle facets on that bottom face. And that was the material that we had to work with at the moment. So get this one out of here. Now that I get this one out of here, I'm going to go over to the lathe and get that next one loaded over there, so we have some stock to play with over on this one. So again, got a little pile of screws here for just making the arms at the end, throwing the arms in. Just showing that the tap's still going, working well. So little machinist snowman arms. So now we should be running the part off over here on the lathe. Just double checking, I'm going to measure my front diameter just because that needs to be able to fit in the collet over there. And it's still maintaining nicely. So we'll be able to bring in the part off tool. I leave it a little bit there so I can actually just grab it off kind of nicely and it doesn't throw it out there. Just kind of program it to the part off to just finish at a certain diameter where it leaves that nub on there. You could get a lead-in angle where it comes in and takes that off, which I've kind of talked about before, but for right now this is just the tool we have available. So I got another one off of here. We'll go start this one again. I'm actually going to make a small adjustment to that program there at the end just because of how it sounded. So what we're going to do is I'm going to slow down that RPM and actually increase the feed rate just a little bit at the end of that program. So we're going to put the maximum down to 2,000 instead of 2,500 and go to feed rate of 2,000 per revolution. Save that really quick. All right, and then we'll keep our op stop on, just in case. So I just got my little stick out ruler here, just bumping it up against that gold part. I give it a good lock just because of it roughing out at the end. Don't want it like kind of grabbing or pushing it back. So now it's coming in that first facing tool again. And then as it's profiling again, we'll go take the part we just did back over to the lathe. Then I'll be able to see if there's any questions or comments on there. So I'll make sure I get this profile going over here. All right. Send in that profiler. I just like verifying tools when they come in. And I got that one back turning. Just forgot to grab my part from over there. Just going to grab that. So and it's actually nice, I actually got a visual kind of for if I'm getting the right diameter with these little circle faces on there, where essentially if it doesn't clean up all the way there, then I know that I wasn't kind of comped in enough. Just using these little ER wrenches for tightening the part in over here. Get the correct tool in. And we're good to go again. At the start of the program. So yeah, and I'll go over in a second kind of the touch off for all the tools, kind of that process too, since the runtime on these is a little bit faster than stuff previously. So I'm basing all my my Z0 for over here on the fourth axis is based off the actual center of the fourth axis rotation. So kind of when that sphere in the middle is about a 3/4 of an inch sphere. So this tool comes into about 400,000 positive in Z, which is, you know, just above. It would be like just above what that sphere would be. And it's only going to negative. So like the drill right now is going to negative 0.1. So it's essentially going just past center from each side. And on the next one, I'll go throw a piece of, I'll go show the lathe, kind of how some stuff touched off there. Over there, it's a little bit more basic, but then over here we can show how I kind of can touch off some tools, even just manually, especially for a job like what we're doing right now that's not that critical. For more of a faster setup, we'll kind of reference how I was doing the ones over here. Let me just get another one over here parted off and start it up. Again, take my measurement. Once I get, the only measurement I really need right here, because this profiler is doing the whole thing, is essentially if I get that one measurement good at the front, it theoretically should be good throughout the whole part. So now I got that one measuring good, we'll run the part off on it. See if I like how it sounds a little bit better. And same with the part off, probably would prefer running coolant, but we're just doing it without for the video purposes. Oh, I still had that one at 2,000 there. Okay. Where did I change that? That's what I did. I got another one off of there. So then how I touched off these tools and where I zeroed over here, we'll go reference that. So actually, I did just for my first one, I just kind of brought a tool in by eye actually for setting my X. Just because again, everything that I'm doing on here right now isn't very critical, so sometimes I do fast setups. So I took my engraver tool right here. I brought it along, so in my CAD where the face of my zero on my part is essentially the top of this hat is what I made my Z0 for reference, because that's going to always repeat against the faces there, and that's not really moving that much. So I just kind of made that my X0, and I just bring my tool center over by eye to where that kind of was, and I just made that my X0. For Y, I did actually use the Heimer, but I had my Y0 saved for it, for the center of my rotation in X, or my center of rotation in Y I set with the Heimer originally and was still saved in my system, so that's what I was using for that. And let me throw this one in here and I'll reference what I did for Z. So you would be able to do the same thing where, say I had a reference point like for my Heimer and everything, or a save zero, I just didn't at the moment. I could bring my Heimer in to where I know it is and kind of set my Z0 with my Heimer, but what I was doing just for these parts, so that sphere that I was saying I knew was 750. I come into Y0 here to where I'm kind of over the center of the part in Y. Doesn't need to be perfect, but let's get there. So then I would step down, I'd kind of get closer to the part, just going slower as I get closer and closer. So I would turn on my spindle here. We'll just go 3,000. I just typed in the wrong thing there, so I want it to spin clockwise, not counterclockwise. So and then I'm just going to step it down 1,000 at a time here right now until I see it visually hitting there. Safety first. So I visually see it hitting the material. And again, I'm just using the step increments 1,000 at a time. And once they remove material there, what I'd actually do is I'd go to my offset page. And once I go to my offset page, I'm telling it that because it's a 750 diameter sphere, I'm actually positive 375 above my part. So once my tool is at this position, I would go say that I'm at like plus 375 above 0. And then that would make like 0 for this tool, the center of that rotation. And that's just how I set up these. It's kind of just a rough setup, kind of by eye, quick. Maybe if you didn't have a thing around you, you're just doing a quick operation. So and then even then with my X0, like where the arms fell, if I kind of wanted to just move where the arms were on there, I could have just make a small X adjustment where, say I want my arms to be more down in the center or closer to the sphere. For this program specifically, because it's just doing the arms, I could have just made a slight X adjustment for how I visually want to place the arms on the snowman. And we'll go to reference here really quick what we were doing with the Heimer to find the Y0. See if see if the dial shows up on the, yeah, I think if I go there, it'll show up right. Oh, did I lose my feet on it? Oh no, okay. Just that delay again. So I have, I just went and set a Z0 so I knew where I was at in Z currently. So what I'm going to do is I'm going to go in my step mode again. And we're just going to come until and we're moving in Y. And we're just going to come till that dial zeroes out in Y here. So now that we got a 0 there for Y, we can set it. And now we're going to come up off of the part. And you can see the dials coming off. Now we're going to move to the front. And we're going to go down to that same Z height that we were just at when we found the back. And then we're going to do that same thing here in the front. So right now, I'm getting 646, so I would take a calculator, 0.646 divided by 2, 323. So at my offset screen, I'm going to bring my tool up again. And so I'm at 646 on my Y, I'm going to go to where it's 323 now. So I'm just going to go in step mode again just to get right there. And I'm just moving it steps again, so 326 and 323. And I would set my Y0 there, and that would be the center of my part then. And then if I wanted to go get the Z0 now, say, here, I'll just rotate my A axis here for a second, just so I'm not on that flat. So now I could go do the same thing in Z with stepping it down, because you want to be over the center of your part in Y. And actually, it would be a lot better if I had a diameter here and not a sphere, because I would need to know exactly where I'm at in X to find the correct Z height for this if I wanted to. But just for reference purposes, I would be coming down in Z, and then same way, get until it zeroes out like that on the dial reading. And then if I had all my tools already touched off in the system, I could essentially reset all my tools to be the center of this axis if I needed to at that point. We'll get this one back out of the way. We're just gonna get our tool back in there and start running some of these ones again. And it's good to go. And we're gonna go back over the lathe. Get another one going. Alright, so over here, I guess I just go through a tool touch-off scenario with it. So we'll bring up that facing tool. Which was tool 7. And say I wanted to find a new 0, I could kind of just come to where this is lined up, just with the front of my part. And because I already had like this sticking out, I could set a stick out that I would need to, and then I could just reference this to where it's a little bit buried into the material like I would want, and hit my Z0 now where, and you can see, so my Z0, if I'm looking at my offset screen here, is engaged with the little part, the part there. So Z0 you can kind of set pretty easily like that, or sometimes what I'll do is if I want it to be like right to a tool, you can get the tool in place like this, unlock your material and bump it up right against the tool or the shank of the tool and stuff like that. It's a good way to set it too. And then if I want to find the diameter of this tool for setting it, like say I accidentally set it or had to I took this out completely and I needed to go like refine my X or something like that, we'll just go reference that here. I'm just going to turn the spindle on to 1,000 RPMs. Kind of just go into a jog mode. And this would be like referencing like if I wanted to set the X diameter of the tool I'm doing right now. So I want to take enough where I'm actually getting a full diameter and not the hex. So I'm just coming in a little bit at a time. Probably coming a little bit more than that. I don't think I'm quite past the hex yet. I think there was good. So right now, I'm just backing my tool out, and I'm not going to move it at all from where it was in X. And once I take a measurement here, that's when I would take this measurement where I'm getting like 840, and I would go over it in my offset page, and I would set that tool for 840 diameter right now after taking that kind of initial cut. I'll just go back to running that program. And you set a safe location for doing this tool change and everything. That's a G30 location that you can choose where you want that to be. So if you want it to be closer to the part to like kind of save time, you're able to do that. But then you want to just make sure you're safe to where it's not doing a tool change right now to where one of those tools that would be in the turret would come in and like run up into your part. So again, this is just facing right now. I can show the model I'm working off of in a second here. I just kind of randomly threw a model together. I wanted to be able to actually just make something for my daughter for her birthday, and that's actually where this project originally came from. She made me this little machinist trinket for like my birthday, so I was going to make one back to give to her. That's kind of where the idea originated from. So the model we had going right here, this little snowman, and where I was having some difficulties with getting the engraver pass that I wanted on there. So again, I might still add that later to get the eyes and the mouse, but I just unfortunately wasn't able to get those done before today. I was doing some different tool paths and not really finding what I wanted to for the tool that I had for getting it applied to it, but that would be a pretty good video. Maybe get that posted once I get those onto them, because I'll still have all these blanks, and once the setup is there, I'll still be able to use the setup that I have to reload all these parts and be able to kind of put those on after the fact. I just might have to orient the arms a little bit if I want them relative to that. Then I just got drill cycle, drill cycle, drill cycle, drill cycle, and then tap and tap. So that's like kind of that entire program. And over here, needed to get like regenerated, I guess. Go through and just show the facing and stuff. So yeah, facing. I do the hat kind of first, then it comes and does the rest. I actually kind of like the angle that it just put on there, so I just left it. I thought it kind of looked unique. And again, even though he's a sphere down here, just based on the stock that I have and using the hex stock, I just kind of like those facets that were left on there. So and then yeah, the finished profile just does the whole thing at once and does a flex pass, and the part off comes in and leaves that little diameter there. And that's essentially both of the programs. So looks like the other snowman is almost done on the lathe, but we still have to finish this program on the one in here. That's the drill part. And go. Yeah, hopefully get some more assembly type jobs here going in the future with stuff. I know it's fairly basic, fairly simple, but by all means, if anyone has some questions for some of the processes or going to anything more in depth about the 4th axis programming or anything, feel free to ask any questions. And if anyone would like a snowman, let us know. I might be able to do something. Go check the profile. Measuring good. Send it. Part offs are always the most fun. Grab that one out of there. And the other thing nice about the hex is you could be able to throw it in the vise if you needed to, be able to grab onto those flats pretty easily, orient it. Set it down in there. put our new one over there. Yeah, the right tool in there. And yeah, we're gonna get the profile going on the other one since that runs a little bit longer. Kind of like the nice thing too is once you get a job going, it's about kind of finding that flow between them and seeing how long you can kind of be at one machine to utilize it. Maybe pre-op a few off of one to get it set up for the other one before you kind of, so you're not walking back and forth as much between. Kind of always build those processes in it as you're going. Get a nice lock up again. This one should be good. Starts a little bit slow. Should just be able to turn the op stop off for this one now. Guess if I hear anything really bad, I'll run back over there. Yeah, that's pretty quick for changing out tools if you have a job where you need to change them out. As long as, I mean, that's where I said, as long as you're programming kind of efficiently, where, like, if I would have had that program, you know, spot one side, drill one side, tap one side, and then spot, drill, and tap the other side, that wouldn't have been, like, the efficient way to go about programming that. Not that this is the most efficient either, but there was least efficient ways, less efficient ways. And the end mill I'm using is specifically like the diameter of the tap, so even though there's a little bit of a hole at the start of there, it doesn't really stand out as much because it's the size of the screw that's going to be going into it. Because it's a 3/16 end mill, 1032 tap, so like 1032 major is like 190, so just over the 3/16. Done. Blow it off a little bit. Get my arms all put in. I had another one over here. I forgot to put the arms in on. Make a little snowman army. I think we were gonna start naming them like Chippy, Spinny. Forgot all the names that we came up with them. Oh yeah, so we normally have different places. A lot of times, so you cannot keep them in the ATC simply because of the wire. There's no way of like not really getting it to orient and not have that like cord kind of get all jammed up. A lot of times people will set them here. People have made custom types of fixtures for like kind of placing them here too, over to the side as well. And that's, I feel like having it, because of, let me go grab one and reference where they come from, like where the cord is plugged in. No, and random questions are the best questions. So I'm just got the Pro, so we only got one in here at the moment that we're sharing between the machines. So just gonna go show plugging it in around the back here. So when it kind of feeds in down around the back, because it plugs in over on the right side of the machine. So a lot of times people have them like mounted here or something like that. I feel like a good position where you can kind of get it in and out to where that cord's not really in your way and not really as much of a trip hazard. That's normally where I'll try to keep it, but right now a lot of times it ends up just being kind of like right here over on the table, just because that ends up being the most utilized spot for us currently with what we got set up. Otherwise, if you had just like maybe some type of like holder case like this or some type of thing mounted to your machine where you could put it in like an actual BT30 taper type of holder. I'm gonna go just grab that other part out of the lathe, get a new one started. Yeah, that's running nice with the op stop off now. The only thing about keeping that op stop off now is if I wasn't getting a good measurement on my part, I wouldn't be able to really rerun it after that part off gets done. But it was repeating, so I kind of trust it now after having enough repeat. My little stick out wand. I gotta give it a tight lock up. And yeah, this program should just be good to walk away from now. Yeah, this one I wasn't sure how many I was running, but I could have got the bar puller set up for this one. Actually, just kind of auto ran it, but just wasn't actually sure how many I was going to be running over on this machine. Yeah, I've seen a lot of people have their own little mounts right there. Even like you could even like 3D print like a magnetic type of just like BT taper holder just for the one Pro. Because I actually normally like always having my other tools like kind of set up over here, but just how that probe comes around that side of the machine, I just feel like it would make sense for having the probe kind of set up over on this side. I get my right tool in there again. Yeah, in hindsight, if I could have made just that middle one a diameter, I could have engraved it better. I just, again, for my tool path, that's more of a fusion thing that I would just hadn't played around with it as much and couldn't really get it to do what I wanted to do in a short period of time. But now I get to play around with that later tonight, see if I can get something good on there, get these loaded in later. I gotta do something over here too where I actually just take the nubs off over on the manual, or like a manual mill over here. Do that in a second. I'll load some of these in and start taking the nubs off over on the mill. I don't have a program or anything set for it right now, but I'm just going to throw in a tool, come bring it into like a location, and just take like a single pass back and forth in Y across all the parts to remove those nubs. Just because with how I ran them from the hat to the part off, they're all going to have like that repeatable kind of length among them. So right after this tool run though, go try to find I got a tool over there that'll work for that. So I can actually leave the part that's in there. I'll just start with this part that's in there. So I just got a 3/8 end mill here. We're just going to bring this down. Kind of, again, just doing this all manually and kind of by eye right now. Not always the best way to do machining, but sometimes it works. I'm just getting it just past the diameter on the little thing that I want to cut. So we should be good there. We're going to crank on the spindle, throw it up to like 5,000 RPMs. Now we're going to move slowly just because it's not knowing exactly how the cut's going to perform right now. See if I got to move in an X to actually remove it off or not. I could probably go faster than that too. Sounds like my part off's done on the lathe over there. Gonna stop and view it, just see if I cleaned up all that flat. It's there just a tiny bit, so maybe just like a little bit in X. So I'll just remember where this tool is. So I pretty much got to come to like 1/920 in X. So I'll just retake that pass. Again, we're just trying to get those nubs off of there right now. So, and actually, with how we're doing it right now, I might as well just start in the back because it'll be easier to load and unload. Even though I was trying to take a climb cut instead of a conventional cut for what I was doing. Which, the difference between that is like climb cut is kind of climbing into material. Conventional, like if it was coming that way, it kind of, the start of the tool would be engaging at the other side of it. And you can always look up more about that. I can go more into depth and climb conventional cutting if somebody wanted me to, but it's kind of all I was going to touch on it for right now. So yeah, I got my little nub off of there. And again, we're going to load the Snowman that we've already done now. Yeah, we could even throw them in there with their little arms. Won't even matter. Oh, no, see, we can't throw them in there with their arm because then I can't lock my part. So we're going to have to take the arms out. I lied. Could go get like an adjustable wrench or something, but we're just going to take these arms out for now. Now we're at the location we need to be, an X. So we should just be able to bring it right through. Kind of just double check where I'm lined up, make sure I didn't make any big mistakes. Safety first. Oh, grabbed too much on it. That was probably just too aggressive of a cut from where I was trying to go. We'll just throw that one back in there, redo it for what we're doing. That's the fun part about doing stuff on the fly. And it's kind of both. It's just the type of the hold along with the engagement of the cut. We'll just try to slow it down. And I cranked my feed rate up there too from that previous cut. So that probably was a factor. Nothing, you know, you gotta throw a few parts though to have fun. And I moved a little bit in X, so we'll see where that is now. just make up some numbers as I go here. See if that just cuts off the nub where I want it. Yeah, that was probably good enough. I probably didn't even need any more of that. Let's just step in, see where that actually is. This was kind of stepping until I heard it touch that wall. Yeah, so I was probably just going a little bit farther than I needed to for that other cut when I kind of grabbed it out of there. So we'll go try another one just at that feed rate and cut, see if we get better results. No, we don't have any. I haven't seen any currently. I'm actually kind of in the process of researching some of that myself for a washdown, because I'm usually I'm used to a washdown as well. I do like the design of these enclosures for at least being able to just brush the stuff down into there and not having to use a dustpan to get it out of the corners, and being able to just kind of trough it down into there and then pulling it out from here and being able to just pick up the chip pan bucket. That's definitely a quality of life upgrade. But yeah, currently I don't know of any wash down or modular types of things, or add-ons for that specific scenario. All right, let's go try this again and see if we're gonna throw it again. Go back into my slow mode. Let's see. It's loud just because of how it's engaging it, but that was actually okay. I mean, there's a lot of vibration being sent through it just because this isn't the most ideal way to engage the part. But we're just trying to make up something on the fly as a way to get off those little nubs so you can sit the parts flat. Stand up nice on the table now. Got about 10 minutes left if anyone has any more questions. Gonna cut a few nubs off of these, go back over the lathe, maybe run them one or two more. If anyone has any ideas for anything they want to see maybe in the next live, by all means drop a comment for what you'd like to maybe see get done in one of these, and we could try to tackle those too. Hopefully be able to build it up, get more advanced as we go. Kind of keep it simple to start. There's probably some, maybe even my spindle down a little bit might help here. We'll try. See how it sounds. Yeah, it's just because of that nub coming off. I think that spindle slower did help a little bit though. Should be able to just crank that there. Probably could just leave it there, but probably not safe. Might just rattle off when it actually goes to cut. Ooh, close. Probably should keep that door closed when I'm doing it just in case it wants to throw a part at me. Yeah, see, once that actually goes, start cranking a little faster. And then when I'm going from fast to slow here, when I'm holding shift, I'm going in the full speed of the machine, and then when I stop holding shift, I go into like the feed rate that I set it at for hand jogging. You know, close the door just in case I want to throw a part at myself. I just wrap it back the other way. That was all of them for taking the nubs off of them. Got one or two more over here. Oh, yeah, we had a few more over there. I guess, you know, while we're having fun, and we only got 5 minutes left, I do have some steel ones that I wasn't sure if I was going to be like running throughout the demo. We're going to throw one steel one in there, try to get the holes tapped in there, modify the numbers a little bit, see if we break a tool in the process. And I'm not going to do the nub on this one just because of the steel and how it's engaging with that nub. I just don't want to get any random wear right on a spot on this tool for any reason. I can just go take that one to a belt sander or something after the fact. We're still going to put in our end mill here. And we're probably going to run coolant for all the tools that we weren't before when we were doing aluminum, just because we're at the end here. And again, we're going to be adjusting some of our speeds and feeds. Actually, I'm really just running that last program at 50% for where I'm at right now. And like I said, I'm just going to want to run some coolant here. I'll make sure I'm closer down there first. Alright, now we should be good. Started getting rough there at the, I went a little bit too deep. Probably should have pecked it. Let's just see if I got some major tool wear on it. No, we'll be good. I accidentally just hit reset on it, so I just gonna run it back in that first hole again. We'll get my coolant right down at it too. That'll probably help. See this is what else we got here. Oh yeah, I'll be able to get some, I can definitely do some, making some soft jaws and try to get that in my next one. Try to get some oblong profile shaped part and get some soft jaws made for it. Show kind of both of the profile getting cut and then plopping it. Maybe, you know, get two vices set up one by side, a op1, op2 vice, kind of traditional setup that you'll see in a lot of places. So I think that could definitely be a good video. So let's just see if I'm still gonna break a tool here in my steel one. Yeah, it starts to sound really rough here at the bottom, but oh, that one wasn't that bad because it had the coolant on it. That other one didn't have direct coolant, so it sounded really bad. Alright, let's get the drill in here. How fast will I spin in this? Will I spin in it really hot? Get my coolant on it again. No, I think we're good for this drill, especially with coolant. I think we might run a couple minutes past, but we're gonna, you know, finish what we got in the machine here before we end this. And again, I'm just kind of adjusting these numbers percentage-wise for speeds and feeds. Don't even have anything really critical with what I'm going on right now. Making some nice chips though. That's what I want to see. It's really going to be on how the tap performs in this material based on if I got some wear on it or not. Well, got through the one side. Yeah, not sure exactly what kind of stainless steel it is, but it's a stainless steel in the machine right now. So again, just running a little bit slower and conservative where, I mean, I could probably crank it up from where I'm at right now on the speeds and feeds, but still just wanted to be a little bit more conservative for just doing one. Making nice little chips there. And it's probably going to make some noise as it breaks through into the other hole. Oh, no, sounded good. Alright, now the real test. Let's see if I can break a tap at the end of the video. Going back up to my 100% just for this. Good, it should be fine for that. See if I can get it. There we go. Alright, go big or go home. I mean, I know it's a fairly simple thing, but it just, sometimes, you know, not proving out something and then going live is more what I'm worried about. Oh, no, we're good. Guess I should have been running steel ones the whole time. Make sure this one comes out of the machine, throw some screws in there. Then I'll probably call it a wrap after that. Get you lined up here. Alright, see if my screws go in. There, now I got my little steel snowman. Got my one steel snowman. Alright, well, it was fun, guys. Think we got a good idea for the next one with a suggestion from Ray there. So yeah, we'll try to get that one done for the next live. So till then, see you guys later.